start discussing ports, and of course there are multiple ports available. Two basic ports that actually we'll start discussion with is serial port and parallel port. So can somebody point out the difference between serial port and parallel port? Can somebody point out the difference?
So the data is stored in serial or parallel form. In serial, one bit goes after the other. In parallel, we can transmit multiple bits at the same time.
Right. So, I mean, it's about how data is going, whether data is going one bit at a time or it's going more bits at a time. So when it's going more bits at a time, we'll say that these bits are going in parallel. So that's a parallel port. So can somebody tell me about the advantages and disadvantages of parallel and serial port? Although we'll discuss that definitely. But
So serial is slower than parallel because of the single bit transmission, and parallel I think has more chances for error.
So yeah, I mean, first point is right, because I mean it is quite evident. You are sending one bit at a time and you are sending multiple bits at a time. Can somebody elaborate on second point? So what is the meaning of being more chances of error? Anybody? Except Ishan. And even if Ishan knows that is also fine.
Sir, we can perform multiple tasks in parallel.
Say again, please. Your voice just got cracked.
Sir, we can perform multiple tasks in parallel.
Yeah, but I mean, is there a drawback associated with parallel thing, or it's all good with parallel? Then why we are wasting our time with serial?
So speed will be less in parallel.
Yeah, that's what I'm saying. So that's what actually Ishan pointed out, that serial will be having less speed. But what is better thing with serial? I mean, why at all we are talking about serial? In fact, I don't know whether you have heard or not, people say that serial bus is more useful than parallel bus. So it is little counterintuitive that something that has less speed, less useful, seems to be less useful. People are claiming that.
Sir, it will be using more wires, more wire, like more connection will be required to transfer data.
So, I mean, what is the problem of carrying in more wires? I mean, wires does not cost much, right? Particularly the kind of lengths you are talking about. So, and even if it's a cost, is this the only reason?
Sir, no, sir. Maybe because of the complexity of the circuit.
In fact, it is less complex because because data is coming in parallel in general. It is not coming in serial, right? You have a bus inside your system. So you have to put in an extra circuitry that will convert it into parallel to serial. And then and on the other end, it has to convert in parallel to serial. So while using serial, it is getting a little more complex, isn't it? Yeah, please. Anybody?
So more power consumption in case of parallel. Not sure about
Why?
it.
I mean,
So because like we have to send a lot of data like in a parallelly, like in a parallel manner, so we'll
so
require
I mean,
more
everybody
power.
is going in its own path, in its own electrical path. So in a way, they are not. I mean, using each other's energy. So I mean, typically it should use almost similar kind of energy. In fact, you will be needing probably little less control signals for that. So yeah. Anybody?
Sir, what is it? What's the benefit? Sir, what is it? What is the benefit?
That's what I am asking. No? That's what I am asking from you guys. That you will answer me something. Except you 4-5 others, if they are awake or they have not just kept their mobile logged on, they can also answer. Okay, so those who are from electronics will appreciate it little better, but computer science guys will also understand this. So electrical guys, if they have done some communication course, they'll be they must be aware about some kind of response of channel. Right. In fact, these wires, these electrical wires, are like channels. So you are pushing some signal from here, you are taking out some signal from here. So what these wires are supposed to do? These wires are supposed to do nothing. I mean, they have to transfer this signal as it is from this place to. Okay, sorry, I probably forgot to share my screen. Oh, sorry. You can see my screen. So this particular kind of channel that I have already drawn even before sharing, sorry for that. So it's supposed to shift signal from this place to this place. And if you, see literally what is going to happen. So these are electrical signals mostly. So there will be some pulses that will be coming out. So something like this, right? So you should input these pulses here and output should come like this. That means the voltage should immediately increase and it should immediately decrease. It should immediately increase and it should immediately decrease. That is never possible. So many times you use signals like this. Right, and you expect that because of this slow behavior of channel, this duration will actually take care of this. You are getting what I'm trying to say? So channels are little slow than a pulse is expecting it to be, right? Is it okay?
Yes, sir.
And it's not the end of story. So the point is, this kind of slowness or this kind of fastness changes with the frequency that you are transmitting within it. So you are transmitting different frequencies at different times. So probably you are transmitting a signal like this, or you are transmitting a signal like this, or you are transmitting a signal like this. So for all of these, for this, this kind of slowness in the channel is different. Communication people or electronics people call it frequency response of a channel. So frequency response typically should be, okay, so let me use my clear board. So, this is my frequency axis and this is my amplitude axis. An ideal channel should have a frequency response like this. This is called white. So, it is giving same kind of amplitude response for all frequencies, but it actually never happens. So there is some kind of different behavior for different channels, different frequencies. And because of this, there is something called skew. Have you ever heard this word skew? Huh? Have Have you heard this? Have you heard this word skew?
No, sir.
So there is a skewness comes into the signals. So for shorter distances, if you are transmitting, you're transmitting through multiple pipes. So using a parallel port means you are transmitting through multiple pipes. So some signal is going from here, some is from here, some is from here, from here, some is from here, and some is from here. And supposedly you are sending some signal from this, another signal from this, another signal from this. So at particular instant of time, the pattern that you are sending was, let's say, 1 1 0 0 1 1 1. And after that you send maybe 1 0 0 1 1 1 0. So these all bits should reach at the other end together. Then only you can figure out, okay, what was sent in this byte. And then these all bits should reach together. What if a few bits are reaching, let's say, these 2 bits are reaching on time, and these 2 bits are delayed, and they are reaching with this. And then this bit is also, this is even delayed, this is reaching with third, and this is on time, and this is delayed. So in a way, you will be receiving half the byte here, and even here you will be receiving something different. So maybe 1 1 0 1, and nothing you will receive here because that is even delayed, and then 1, and then 0. Getting my point? So your bits are not synchronized at the end of parallel channel if there is a skewed behavior coming into picture, while at the start they were synchronized. So this loss of synchronization will be more if there is a length of channel is more. So if your device is little far off, this loss of synchronization will be more, and you will be encountering more trouble. So this is the problem with parallel ports. In serial port, it is nothing like that. So what is actually happening? You are transmitting 1 after 0, then 0, then 1, then 1, 1, then 1, and then 0. Let channels skew the bits. Even then, there is no loss of synchronization. So it can be transferred to a larger. Are you getting my point? Any confusion about it? Is it okay? Am I audible?
Yes, sir, it's fine.
Yes.
So are you getting this point?
Yes, sir.
So the point is, of course, your parallel ports are faster enough. They are simple. Serial ports are slower. They are complex. But for a large distance, you cannot use parallel ports because you lose synchronization. For a smaller distance, that's okay. The kind of difference can be managed. And for serial ports, you can go for larger distances, right? So now, let's see it more closely. So when you talk about interface circuit, you are actually transferring some signal or data over a circuitry from computer bus to IO device. And what all you are transmitting? So you are actually transmitting address, and then you are transmitting data, and then you are transmitting control. Right? The point over which this is connected, this interface circuitry, so we connect a wire through that. So that side is called port. And I mean, of course, as we discussed, that there are two kind of ports, parallel port and serial port. And we'll be talking about even more standard kind of standard circuitries, but those will be either serial port or parallel port. I mean, for processor, it is going to be same, whether it is a parallel port or serial port. Processor does not bother whether it is a parallel port or serial port. It is the circuitry that has to make the conversion from parallel to serial and serial to parallel at the other end. For processor, it is always a parallel port. So let's see the block diagram of, and then of course circuitry of these this parallel port. So can you see my slide?
Yes, sir.
So there is a processor, of course, that is the center of attraction. And this particular thing talks about a keyboard to processor interface parallel port. So there is a keyboard switch. Keyboard switch means there will be a keyboard and you will be actually pushing buttons over this. And then there are two other blocks that I'll talk about what these are. So this is one is encoder and debouncing circuit, and another is data in SIN and input interface. So till this point, this red point, everything is actually the device side thing, and then in between there is a wire connected, and there is a processor thing. Probably you can see my cursor running here and there. Here, encoder and debouncing circuit, let me explain you. This is specific to keyboard, or somebody can explain me, then it will be better. Can somebody explain me what is encoder and debouncing circuit? Anybody? So when you press a keyboard, and because you are pressing it, so you will be pressing it for non-zero duration. Of course, I mean, for a larger duration as far as a processor is concerned. So processor can think that you have pressed key for a number of times, although I mean it is happening for a couple of milliseconds maybe only, but for processor this duration is pretty large. So this kind of impression system may get that you are pressing key for more than once. So to make sure that this kind of impression must not go, there is a debouncing circuit used. So debouncing circuit ensures, and you can do it using software or you can do it using hardware. This particular block diagram shows a hardware approach. So this ensures that no signal will be passed unless otherwise there is a debouncing happen. So you have pressed a key, as long as the key is not coming back and pressed again, no signal will pass through. So this is a debouncing circuit. And of course there is an encoder circuit, so the key you have pressed that will represent to some character or number. So that will be encoded in terms of bits. And then after that, you are coming for a data. And a valid thing means whether this signal is valid or not. And this data in SIN, this is actually one is your status bit and another is your data, where your data is coming. Processor will read this SIN bit and then only it will read data from it. So data will pass through this, and of course address will be here because we are talking about a memory mapped circuit. You have already seen this R and W bar. So whether it is a read signal or it's a write signal. So it's a read signal basically. So it will be 1. And then a bit of handshaking that you are already aware of, master ready and slave ready. So that is already there. So this kind of block diagram, a parallel port will be having. Does it make sense to you? Any confusion or any question about this? Any confusion or any question about it?
No, sir.
So I should go ahead. Yeah. So this is a more elaborated diagram of the input interface circuit. In earlier thing, you will be actually seeing the block diagram only. Here also it's a kind of block diagram that is also representing the gates. So you can see here that there is a keyboard data that is coming, and then there is a data in register from which it will be passed through it, and then there is a SIN signal, so that will actually be enabling this process. It is a status flag that you can see, and then there is an address decoder. So if you'll go on the previous slide, so there was an address bus that is coming. So if address bus is coming, address decoder has to be there. So this is address decoder. For data bus, this is data bus is coming. So data direction is this because it's a read signal. And yeah, of course, there should be a master ready and read and address thing should be, or then only this should happen. So these AND gates are ensuring that. Yeah, I think I have explained all the things. And it's a 3-state driver. So low, high, and high impedance state. So if this is disabled, this SIN will not ensure, this 3-state gate will not pass anything through it. So one SIN should come, and then this should also be high. Then only the data transfer can happen. So this will actually be connected to all the data buses, right? So, okay, we can look at what is written there. So SIN signal is generated using a status flag circuit. You are aware of it. It is connected to line 0 using a 3-state driver. So this is a 3-state driver. And address decoder selects the input interface. And so, whether status or data register has to be read. And in response, processor activates the slave ready signal. So this is the kind of more closer look at input interface circuit, right? Make sense? Is it okay?
Could you repeat the last line?
Can you speak up a little loudly?
Sir, could you repeat the last line? Your voice wasn't clear.
Last slide. Okay.
Last line.
Last line. So, which line you're talking about? So, okay, let me explain everything once more. So there is a status flag that will actually ensure SIN to come to a 3-state driver. There is an address decoder where A0 is separate and A1 to A31 is actually going through address decoder. All these buses are coming, all these values are coming for address. A0 determines whether status or data register has to be read. That means this or this has to be read. And processor activates the slave ready signal. So when either read status or read data is equal to 1, so that will depend on line A0. So this way this transfer will happen, right? So when this will be 1, the data transfer will happen. Make sense?
Yes, sir.
For everybody?
Yes, sir.
Okay. Now let's see other way around kind of transfer. So in previous transfer, we are talking about something where data was passing from a device to processor. Now we are talking about a printer. Now processor is putting some data to a device. Still, we are talking about a parallel port. But the direction of data transfer is now changed. Right? So here you can, one of the major differences you can see is that your data direction is now changed. And of course, debouncing circuit is gone because there is no more keyboard debouncing. And of course, the address bus is as same as it was earlier. Whether it is a read signal or it is a write signal, that is another question that has to be answered by processor. And then again, handshake part, that is master ready and slave ready. And here, in place of data in, now there is data out register. And in place of in SIN, there is SOUT bit that will be actually coming from flag register. And once passing through this output interface, you will be actually giving data to the printer, right? So there are two things that has to be seen. So ideal signal line which the printer asserts when it is ready to accept a character, and that actually turns out as slave ready signal, and as out flag set to be 1. And whenever this happens, so processor places data into data out register, and once it is put in data out register, it will eventually be passed through printer. And for this, a valid signal will be asserted by the interface circuit over the printer, so that this data can be transferred to the printer. So this is the block diagram process of the parallel board for output. Make sense? Okay. Again, now this is a more closer look for output circuitry. You won't be finding much difference here, except you can see that there is a block that you call handshake and control. That is additional here. Right? Is it okay? So let's see. The data lines of the processor bus is connected to data out register of the interface as previously, but the direction is reversed now. Status flag S out is connected to data line D1 using a 3-state driver. Again, as the previous thing was this, but now this is S out in place of S in. And again, this 3-state driver, the third state will be actually controlled by RW bar, master ready signal, and address decoder. That means A1 to A31. And address A0 again determines whether data is to be loaded to data out register or status flag is to be read. What you are going to do, which address you are going to use, that is actually will be dealt by this. And if load data line is 1, then valid line is set to 1. And if ideal line is 1, then S out is set to 1. That you can see lines are going this like this. Now, this is little more complicated circuit. I don't know if you can see it properly or not. Can you see this circuit properly?
Yes, sir.
Okay, so it's a combined I/O interface circuit. So we have seen an input circuit, we have seen an output circuit. Now we are seeing a combined circuit for data transfer. It is a combined interface circuit. One important thing you can see here is, I don't know if you can see it or not, there is a data direction register, DDR, that actually ensures about the direction of data. I think I'm also trying to find that out. Okay, so sorry, this circuit is actually spread through 2 slides. So here you can see that there is a data direction register. This data direction register is actually tells you in which direction you have to transfer the data, whether you are going for input or you are going for output. And additionally, the data lines are bidirectional. So because you have to transfer in the data in both the directions, so you have to transfer in both. So you need something that is both directional. Data lines P7 through P0 can be used for both input and output. Similarly, here D0 and D7. And this DDR register is controlled by processor. So 8-bit pattern is placed in processor, and this decides whether it's a input operation or it's an output operation. And then you can see that in status and control there are 2 lines, C1 and C2. This controls the interaction between the interface circuit and I/O device. And you can see that there is a line INTR. So, I mean, this is actually something that goes to the interrupt line of the system. So, if you want to interrupt the system to transfer the data. And ready and accept are actually, again, same master ready and slave ready kind of handshake signals. So this is the basic idea of a complete bidirectional circuit. Actually, you will be having this circuit only. You will not be having either input or output circuit. You will be using circuit only most of the times. And then accordingly, the device will be used. Make sense?
Yes, sir.
Okay. Now let's move on to serial port. We have already discussed a bit about serial port. So the idea is it will transmit 1 bit, and processor will look it as a parallel port only. There will be conversion from parallel to serial and serial to parallel at both the ends, right? So, yeah. So this is our serial port circuitry. So you can see that here serial input is coming. This input shift register will convert into parallel here. And after that, the idea is pretty much same. This will be actually D0 to D7, and then there will be 3 state buses. And in the same way, there will be a data out thing. And then there will be shift registers that will be converting this into the serial bits. So input shift register accepts input 1 bit and from the IO device. Once all 8 bits are received, the contents of the input shift registers are loaded in parallel into data in register here, and output data in data out register here, and bits are converted into serial. So this we have already discussed. So yeah, so this we have already discussed. And this particular idea, because you are buffering it twice, so this is called as double buffering. And rest everything is similar to parallel port. Only point is you are converting it to serial to parallel and parallel to serial in both the ways, right? Any questions, any doubt about it? Any confusion, any question? Am I going too fast today?
No, sir. No. Sir, we studied some microcontrollers last semester which are exactly like this, no?
No, so you are asking a question or what?
Sir, I'm asking if this is the circuit to those microcontrollers like 8251A and stuff.
It's not microcontroller precisely, but yeah, microcontrollers will be having these kind of circuits available with them. So I think you must be aware of the difference between a microprocessor and microcontroller. Are you aware of this?
Yes, sir.
Can you tell us?
Sir, the processor is the main unit controller, acts like an interface as from what we've learned.
Yeah, so basic idea is in microprocessor unit, you only have a microprocessor over chip, whereas in microcontroller, you have some peripherals along with microprocessor. So there will be some kind of ports, there will be some memory, many times there will be a coprocessor as well. So microcontroller is a single chip computer. So you'll be having peripherals along with microprocessor. And when you're talking about a processor only, the chip will only be having a microprocessor. So for example, your Pentium 1, Pentium 2, these all are microprocessor chips. Whereas you're talking about 805 and all, these are microcontrollers, right? So interface will be, interfacing will be interesting and important in case of any microprocessor or microcontroller circuits, that one must understand this. In fact, this course is quite useful, and particularly this unit is quite useful for the students who wants to do in device driver writing and things like this. I don't know if except ML you want to do anything else or not, but even ML codes will run on these kind of microprocessors, and ultimately when you have to go to hardware, you have to understand these things, and then only you can make something like this. But those who are doing higher level programming, they don't actually need that. Without a lower level circuit, higher level programmings do not work. Fine.
Yes, sir.
So should I go ahead?
Yes, sir.
So there is some more description about serial port. So must be requiring fewer wires and convenient transfer will be there. Speed of transmission of data rate over serial interface is known as bit rate. And of course, there will be, there are famous serial ports are UART, Universal Asynchronous Receiver Transmitter, and RS-232. So these are the famous serial ports. I think RS-232 you must have heard about, but even if not, you will see in some later part of this program. Now this is important. So by now we have seen the general idea of data transfer. So we have seen a serial port, we have seen a parallel port, and probably even understand that this circuitry will be different for different kind of systems. But this cannot work like this. So then there is some kind of standardization is required. So I mean, every system or every vendor should follow those kind of standardizations. So then there are few standard I/O interfaces have been defined. USB is of course one of them. We'll be discussing about that. That you have heard about. I don't know if you have heard about SCSI or not. That is another standard interface that people talk about every day a lot. So we'll be seeing few of the standard interface circuits maybe in this class a bit, and then probably in the next class. So a personal computer has a motherboard which houses the processor chip, main memory, and some I/O interface, and we'll be talking about few of them, right? So these kind of three bus standards we'll talk about. One is PCI, Peripheral Component Interface. Later on it converted to PXI. If you have heard about National Instruments, National Instruments actually uses PXI very extensively. And another is SCSI, Small Computer System Interface. That is also pretty famous. And then one you are really aware of is the USB, so Universal Serial Bus. We'll be talking about these standards in detail. At least the detail you can appreciate it. And yeah. So this is the kind of general idea for standard I/O interfaces. So you can see that there is a processor, and then there is a main memory, and there is a processor bus. The most important thing here is bridge. So I mean, whatsoever you are generating here, and this whatsoever you are generating here is most of the times proprietary. You have to put in a bridge circuit that will convert everything as per the standards of PCI or PXI, whatsoever bus you are talking about. Here we are talking about PCI. So as per the standards of PCI bus. And then in PCI bus, you will be having different things. So like additional memory may be there, SCI controllers may be there, Ethernet interface may be there, USB controllers may be there, ISA interface may be there, and there are so many things. So this PCI or PXI is something that actually is an expansion bus over motherboard, and this offers places to different kind of protocols, standards to sit with it. So these all are different standards. So whether it is a SCSI controller, or it is a USB controller, or it's a ISA interface, or Ethernet interface, and then after these controllers, you will be having their corresponding buses, and then there are all the ways and means by which it will be used. Right? Is it okay? Is it okay? Hello.
Yes, sir.
So could you understand the placement of PCI bus and other buses? So maybe you can look at some National Instruments chassis where there will be a PXI bus. This PXI bus will be actually connecting processor and main memory to the different devices, and then there are different slots available here and there, sometimes 8, sometimes 16, where you can plug and play different devices following different protocols. So this is one thing that is very important about PCI bus, right? So this is an expansion bus over motherboard that simplifies so many things. Is it okay? Is it okay? Is it okay?
Yes, sir.
So we'll stop here today. We'll discuss the intricacies of PCI bus and other two standards in the next class. So if so far you have any question, kindly ask, or we'll stop the class here. Any questions? Any questions from anybody? Okay then, see you in the next class.